let's see if we can run through these rules quickly. Right, so the first part of module one, actually module one is broken up into your logic and reasoning, right? Your real number system, right? After you have your real number system, right, we'll take a look at remainder and factor theorem. Then we have to look at the exponent and log functions. And last as well, then you have your functions, all the rules of functions. And then you have modulus and cubic. All right, so let's start here. Right, we'll split it in two, right? We'll start with logic and reasoning, real number system, and indices and logs, right? And then we'll do questions and we'll come back and do the next part. All right, good. So let's look at these rules here. So the negation of R is written, not R. You should also be able to put this in a truth table, right? So for example, if you have R, negation of R, the two options is what? True and false, right? And the negation will be false and true. That's okay. One quick thing I wanted to remember though, if you have only one proposition, then you only have two options, right? Right? What about if you have two propositions? How many options you have? Four, right? So that'll be 2 squared. So that'll be true, true, false, false. Here will be true, false, true, false. Right? And what would happen if you had 3? You will have 8 options, right? So that'll be true, 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 false, 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 false. Right? And then you have 2, right? So you have to remember that, right? So you have to look and see how many propositions you have, and then you can set it up this way. All right, are you okay with that? So we need to remember that that if we apply double negation, cancel off, right? Conjunction. Well, I only give you the summary here, right? So I didn't give you the whole table. But in case you wanted the whole table, you have P and Q, P and Q. Right? You have true, 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 false, false, true, false, false, right? P and or conjunction is only when P is true and Q is true, everything else is false, right? So here is true, everything else is false. That's okay? So you just have to learn this summary, right? So it's only true when both of them are true. Otherwise, it's false. Okay? So you don't really have to write down all this. Once you learn it, you should be able to figure this out. Right? This junction, P or Q, right? P or Q is false once they are false and true otherwise. Okay? Everybody okay with that? Conditional, right? P implies Q is false only if P is true and Q is false. Biconditional, biconditional, if P and Q are both true or both false, then it will be true. All right, quickly, converse, inverse, contrapositive. Right? If I give you P implied Q, what's the converse of that? Converse will be Q implies P. What will be the inverse? The inverse is negation of P implies negation of Q. What is the contrapositive? Right? You switch them around, right? So the contrapositive is the converse of the inverse. Are you okay with that? Yeah. So you have to learn them, right? For now, you have a summary and you have How much days, for example, in August? Plenty? 60 something? Yeah. That's too much. You gotta probably take off all the other subjects. Say about 20 days. Right? And you can learn all this out. Okay, so you gotta learn the rules. Right? Converse, you switch them around. Inverse, you negate them. And contrapositive, you switch them around. Okay? So just remember those rules. Right? All of it here. Everything here, right? Right? You have your real number system. One of the things that we have to do is to prove PMIs. This here is the general steps of PMI, right? Your first step is what? Right? We have to prove this. So your first step is to show it holds for n is 1. Second step, assume it holds for p to the k. Third step, show it holds for p to the k plus 1. Then you can rewrite this last line. Okay? And we'll do an example in summation and the divisibility, right? We'll do all of them. All right, next we need to remember remainder and factor theorem, right? Remainder and factor theorem, you should hopefully remember this rule. If you divide a function by ax plus b, then f of minus b on a is the remainder, right? If the remainder happens to be 0, then it's a factor. That's okay? Right? We need to be able to solve and factor at cubics, real easy, trial and error. Then you long divide, then you factorize or solve. All okay with that? Sometimes they ask you this, right? Sometimes they ask you to expand or factorize a squared minus b squared. Right? Sometimes they ask you to factorize that, right? So of course you have to learn this one. To get a cubed minus p cubed, you can learn this off, or what's the next way? Well, what's the next way to find a cubed minus b cubed? If you do, if you do learn this off, right? Long divide, very good, Kyle. A minus b, you divide it into a cubed minus b cubed. That's okay. If you long divide, you'll get this as the answer. If it's a cubed plus b cubed, you long divide a plus b. So let's just say a question said to factorize a to the 5 minus b to the 5. All you have to do is long divide. Okay? Right? Or you can learn this formula off. Right? But you cannot trick it to learn, so it's better to be able to factor long divide, right? Right? And actually, let's get warm right in. Let's start and then I'll do logs and indices because some of you still do like that, right? So we'll spend a little more time on logs and indices. Okay, so let's jump right into logic and reasoning, PMIs and factorization. Right, by the way, right, your if you want to attend doing it all night on the 9th of June, right? 9th of June, right? Because the exam is the week after, right? Yeah. Physics all night. So let's see, I'll pass it this now. Yeah, I'll find it somewhere here. I'll find it. Just send them from up. People is always so, huh? You can send it. All right. Anybody have a soft copy on your phones? So I gotta go and upload them. Soft copy of all the papers, 22 until like 2016. Send them fast now. I don't know how to keep loading them. Yeah, just send them individually, right, William? Please. Huh? Gotta go on just one. Right, let's start with 2022. This should be easy, right? If you're struggling, you can send my little message if you didn't share the top of your hand, right? Some of you are new, right? I'm coming, right? I just trying to get a chat in the next class. Right. Oh, yeah, well, just got it. Right. Right, we got you. Right, negation of, yeah.
Higher response time, negation, sir.
To justify it as basically saying that the columns are equal, right? Well, provided they're equal, right? Negation of Q is what? That's false, true, right? Negation of Q and the P, that'll be false, true, false, right? Because you're looking at here and you're looking at here. And last one, you're looking at P or you're looking at P or this, right? So that'll be true. That will be true. That will be false, and that will be false. That's okay. Just make sure true, false, right? State whether the statement negation of P, that's right here, and P or that are logically equivalent, and the answer is they are not. Right? The answer is no, and the reason is because the truth values yes. So that means all should be close by. Upstairs? Right, so all should be somewhere there. Truth values of Bradley and yes, Bradley. Ali Museum back at unit 1. Yeah, I'm Bradley. Amen. I lost the lab. I can find the lab. To get the old project marker from last year. Right, truth value of I was saying earlier, right? Truth values of both of them are not the same, right? Sorry, all the truth values of the negation of Q and P, and the P or the negation of Q and P are not the same. Right? Or you can say column 1 and column 2, not the same. Right? You just label it. All right? And you're good to go. Yeah? Anybody new? Like new for the first time? Well, yeah. New. Okay. I'm just want to see online as well. I never saw it before. Right. How you find the A, B, and C here? Huh? Expand the right side, and then we can compare the coefficients. That's okay. One other option that's a little bit harder is to write this in this form. It's kind of hard, right? So the best thing to do is what? Factorize the right, expand out the right hand side and then solve the left hand side. Are you okay with that? What you find? Finish. As you get easy marks here. Expand out quick and compare.
I think 70.
Right? Take your time and expand the right side, right? So I would have expanded the two brackets first, and you'll get x squared minus 3x plus 1. That's okay? And then here is minus bx plus 3b plus 2. Yeah? Sorry?
Plus two when x minus two and x.
Oh, yeah. When I expand them down. So that'll be ax squared minus 3ax plus 2a minus bx plus 3b is c. Right? If you want, you can bring them together. And then leave all the constants by themselves. So that has to be equal to 2x squared minus 7x plus 12, right? And now we can compare coefficients. That's okay? That's the only way the left and the right could be equal. Compare them and solve. Right? A is how much? A is 2, right? So you already have A. So you have to find B. And when you find B, find C. All right? I'll give you 2 minutes. Control it. Just click it like. So why is it staying online then?
You say it like me to.
Oh, sorry, online. Sorry about that. Right, so this here was the working for the last one, right? So I compared coefficients A and coefficient of x squared, coefficients of x, and coefficient and constant. Right? Sorry about that online. You all got that? 2, 1, and 5?
Yes, sir.
Yeah, all right. Right, I may not be able to hear you, so you get always message, right? Nice. Try this here fast. It's remainder and factor, right? How much unknowns do you have there? 2 unknowns, right? P and Q. So how many equations you need? 2 equations, right? So from that, we should be able to get 2 equations. All right, I just want to make sure that you have the right I want to make sure that you have the right equations. The set is divisible by x minus 1. So it means f of 1 is 0. And the set when is divided by x plus 1, that'll give you f of minus 1. The remainder is minus 6. That's okay? So basically you're making x minus 1, 0, and you'll get x, right? Solve it. Let's see what you get. I get up for the first one, minus p plus q is 8. Yeah?
Yeah.
Go ahead. Get the next one. Double it on. Enter. Anybody getting trouble with this? Right, so the second equation is what? The second equation will be 2 by minus 1 cubed minus p minus 1 squared plus q by minus 1 minus 10 is minus 6. So this is minus 2 minus p minus q minus 10 is minus 6. So minus p minus q is equal to 6. Hold on. Yeah, 6. Only got 6. We have two equations. We could add them, right? So we could take 1 and add it to 2. Right? You will get minus 2p is equal to 14. Q is equal to minus 7. Yeah, that could work. And that means that Q is equal to 1. Wait, no. Yeah, 1. Q is 1. Anybody got that one line? Everybody okay there? Any questions? Kyle? Sure. Changing it, right? They just to get a little warm, right? These are all the easy topics, right? Right? No PMIs in 2022, 2021, I mean. 2022. Next one, 2021. Any questions online? Right, so you might recognize after a while module 1 should be a graphic module, right? Which module you have problems with? 2? 2 and 3?
Mostly 2. Mostly
Or
2
two?
can be faster within 3.
2 are? 3, right? I'll spend some more time on 3. 3, okay. All right, 21, go again. It's same thing or? No. 21. 21, right? For those who don't know a year is 21. No, not at all, just Bradley, right? You can message me, I'll call him up. All right. Right, negation of P, that will be false, false, true, true. This will be false, true, false, true. Or that will be true, 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 false, 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 true, and double negation will be false, true, true, true. That's okay? Are they logically equivalent? No, right? What's the next way to check and see if they're logically equivalent? What you can do again? What you can do? Huh? Yeah, do a biconditional, right? Good. Right? And they didn't ask us, right? But what is a tautology? All true, right? What's a contradiction? All false. All right, nice. Let's go again. What's the converse of that statement in words? What's the converse of that? Converse means what? Switch them around, right? We will write it fast. What's the converse of that? Nice. So the answer will be n squared is an integer. Implies that n is an integer. All okay with that? Right. Now for our hard question here. What they want us to do is to show that close on the R, right? Let me just re-explain what close means, right? If I told you A and B are real numbers, right? If I told you A and B are real numbers, and then I have to check and see if A plus B is closed, all that means is that you have to make sure that A and B is also belongs to the same set. Okay? So think about it. If A is a real number and B is a real number, and you find the sum of two real numbers, what you'll get? A real number. Therefore, it's closed. So you're applying that same principle here. You have to show that this function is closed. So you have to show that x squared, y squared, add them is also closed. Real simple, but you have to put it in well, mathematical notation. Right? So since x and y are real, try it. I'll give you a minute. 2 minutes. I'll give you 2 minutes to write something nice. So think about x squared. Would x squared be real? Yeah, right? X by x will all be real, right? It wouldn't be real if you can figure out a situation where x by x will not give you something real. But the product of two real numbers is always real. All right? Product of two real numbers is always real. So x squared is real. Well, what about y squared? Also real. So x squared plus y squared is real. Huh? All right, so yeah, so it means that x squared will be real, y squared will be real, and x squared plus y squared will also be real. Therefore, x star y is closed in R. Everybody okay with that? I just asking something, right? Suppose it wasn't a real number and it was a positive integer. Would it also be closed? Yeah, check and see. X squared. Will that always be a positive integer? Yes. Y squared. Always? Yes. X squared plus y squared. Yes. That's okay? And if it were negative integer, let's just see. No, right? Because x squared will give you something positive. All right. Last part, should commutative. Should commutative. What does commutative mean again? X star y is equal to what? Y star x. Anybody have to go and get food? Or you all ordering food or something? All you have? Huh? Let them walk and get something? Where are you going? Order something so you have more time. Or split it up. 5, 5, 5. I was sponsor 5 of those, but I will save all them. Right, so let's start. Y star x is what? Y star x will be equal to, which is equal to x star y. Therefore, commutative. And you're good to go. Are you okay there, Israel? You okay there? Let's go again. I don't want to spend too much time on the main non-factor, right? And do this last one, or we can leave this one out. Huh? Leave it out. Sure. Right, and then I'll leave out the, well, we're not leaving out logs, so we didn't reach logs as yet. Actually, do this fast. Last one. Last one like this. Huh? AX cube, yeah. Yeah, nobody could just download them papers. No, that's huh? I just want 22, 21, 19, 18, 17. And just send them one by one. Please. See if I load the whole booklet is cut off now. Right, the booklet do have 2022. Yeah, cut off. If I do it like that. I would try it though, but William, the booklet do have 2022. Right. I have that one too. I just don't have the. I will try, but it'll cut off if I use the whole book right now. That's why I like it individual. Huh? Emily, you have it individual, like the individual, yes? If you could, like, just send them individual. Please, you can show, sure, Grant, you can show. That's all right. 22 to 60. 22, 21, 19, 18, 7. If you are 22, you can just send 22 in group now. Send 22 in the group. So we will have it. Excuse me, what are you doing now? Right, so it's divisible by that. So that means f of a half is equal to 0. So that'll be a by a half cube plus 3 by a half squared minus b is 0. So that's a over 8 plus 3 over 4 minus b is 0. Right, we can multiply by 8 to look a little nicer. So that'll be a minus 8b is equal to 6, negative 6. Well, look at that, so equation 1. Yeah, Kyle. Next one, the remainder is minus 5. So f of minus 2 is minus 5. So that's a by minus 2 cube, a by minus 2 cube plus 3 by minus 2 squared minus b is 0. All right. So we'll end up with minus 80. Minus 80 plus 12 minus b is 0. Pardon me? Yeah. Thanks. So that'll be minus 80 minus b is equal to minus 17, right? So we can substitute and work it out. So we can see here that a is equal to minus 6 plus 8b. So that'll be minus 8 minus 6 plus 8b. Right, my 6 looking like a b, yeah? So still looking like a b. Minus b is minus 17. How much shall I get it? So that's 48 minus 64b minus b is minus 70. So minus 65b is what? Minus 65. B is 1. Yeah. B is 1. Nice. So a is 2. Yeah. A is 2. Right. Thanks, Grant and Emily. William, good. I didn't get 18. By checking it, thanks. Right, let's take a look at 19. So did you do after the, right? I made A the subject and I substitute A. Right, Josiah? Right, I made A the subject and I substituted it in there. Oh, I got 6 right here. I made A the subject, I carry across in 8B. And I got minus 6 plus 8B. All right, let's go again, 19. All right, show this commutative. Show this commutative, then we have PMI to do. 19. No, forget it. Forget the remainder term, right? Two lines long, two or 3 lines, right? You want to show it commutative, A star B as B star A, right? Thank you. Bobby done. Thanks. Right, so we know that A star B is equal to AB on 2. So B star A, you just switch in the B and the A, right? And since multiplication commutative, you'll get AB on 2. That's all right. Right, since multiplication commutative, A by B on 2, you'll get A by B on 2, right? So it means that AB is equal to AB. Sorry, BA is equal to AB. And then you could say that AB on 2 is equal to, therefore the entire thing is commutative. Right, next, PMI, try it first. It's a divisibility, so it should be short, right? Well, it should be easier, right? Try that it pass. Follow this step, right? Let any go to one. So you don't want to know by.
Yeah.
Yes. Yes. You know that I asked you. No. Should I stop at two? I don't know if it's. Yes.
What is here? All right, so what is here? So first thing first, we need to let n equal to 1. So that'll be what? 5 to the 1 minus 4, which is 4, right? Which is technically 4 by 1, right? One of the things I like to do is this. Let 5 to the n minus 1 be equals to 4a. 4a means it's a multiple of 4, right? Which is divisible by 4. So when you put n is 1, you could say is of the form 4a. So you're good to go, right? Therefore, it holds. Next step. Next step, when n is equal to k, it will be 5 to the k minus 1 is equal to 4. Change the letter, right? Change it to p. So it means it's a multiple, right? That's okay. Next, n is equal to k plus 1. It means that 5 to the k plus 1 minus 1 is equal to 4c. So we have to prove this. We have to prove that 5 to the k plus 1 minus 1 is equal to 4c. So in order to prove it, here's what you do. From here, we could say that 5 to the k is equal to 4b plus 1. Y'all see that there? Yeah? Now, watch this here. 5 to the k plus 1 minus 1. I'm going to simplify that statement a little bit, right? That will be 5 by 5 to the k minus 1. Yeah? Right? Now I can make a substitution. Now I can substitute 5 to the k is equal to 4b plus 1. 5 to the k, so you write in since 5 to the k is equal to 4b plus 1, we will end up with 5 by 4b plus 1 minus 1, which is 20b plus 5 minus 1, which is 20b plus 4. All we have to do now is factor out 4. And you'll get 4b plus 1. Right? I know different people have different ways of doing it. But once you can factor out 4, you're good to go. All right? some people like to substitute for the one, some people like to substitute for different values, right? But at the end, once you get factor out 4, you have it. Are you okay with that? And then you have to write your last line. Since it holds 4, n equal to 1, n equals to k, n equals to k plus 1, then by PMI, it holds for all. Okay, you have to write that line. That line is a mark. Any questions? Israel, you okay with that? Right, we're gonna do a summation. That's the harder one. Yeah, I think might not see that. So, go ahead, I'll give you some time. Write it down. Just write your last line. Right, so I left out the last line. You have to write it in, right? Since it holds for n equals to 1, n equals to k, right? N equals to k plus 1. It holds for all by PMI, right? N is n is a natural number, I think. What was n again?
Yes.
N was natural. All the natural numbers. All right, that's it for 19. Let's take a look at 18. All right, the first one is that I forget that table. Try this here. Find 5 function 2. Try that fast, easy marks. Yeah, there's 18 now. 18. There's 18, right? Finish? Hurry up. For those who finish, I think they asked for commutative after, or close. They asked to close after and then commutative. They asked to close after and then commutative. Close, then show it determinative commutative. All okay with this first part? So 5 function 2 will be 5 function 2 will be 2 by 5 plus 3 by 2. 16. Everybody okay with that? 16, yeah, Olia?
Yes, sir.
Next one is function B is closed, right? How we doing that again? That more than prepare. What is do? Oh, you gotta figure out something. But... All right, William helping you. Yeah. Well, A and B are real, right? A and B are real. They told you that here. So what you do after? No, you see, you can't try one number. If you're using proof by exhaustion, you have to use all the numbers. So what you have to do is, since A is real, then 2A is also what? 2A is also real, right? 2A is real. So if A is real, then 2A is also real. And 2B will also be real, right? All these are axioms. Any number by a real number will give you back something real. So if you write it, you're good to go. 2A will also be real. 2B will also be real. What's the last step? What's the last step? Then 2A plus 3, sorry, this must be 3, right? Then 2A plus 3B is also real. That's okay? Because there's a real sum of two real numbers is real. That's okay? There's a rule, sorry. You okay? So you can't choose one number. You have to use a whole set of numbers. So if A is real, then 2A should also be real. If B is real, then 3B should also be real. Right? You can't prove by exhaustion because you want to quote all the real numbers. Right? So that's an incomplete proof. Well, you could try contradiction. If you could find a point that will not work, contradiction could work. Right? But there is no point that will work, that will not work. Right, yes. So to prove close, the answer is yes. So we prove it, right? Therefore, A function B is closed in R. Okay? So determine if commutative first. Determine if commutative. You listen to what Shabara said, if it's commutative or not. Try it quick. Commutative. Israel tried the thing now, boy. It's finished already. Oh, you're checking this one. Yes. Yeah, if you want, but that's not proper proof, right? Because if I choose are there any bars we could choose that would be equal? Yeah, they choose one that wouldn't work. Yeah, so yeah, so you could probably use exhaustion here, but that's more like contradiction. Exhaustion means using all the possible values. So contradiction will work here. Like use one function 2 and use 2 function 1. That could work. Right? But it's very simple just to do this, right? A function B is equal to 2A plus 3B. That's okay? So what is B function A? B function A will be 2B plus 3A, which is not equal to 3A plus 2B. Sorry, which is not equal to 2A plus 3B. Right? They are not the same. Therefore, not equal to A function B. So it is not commutative. Everybody okay with that? Online, all okay with that there?
Yes, sir.
Right? That was what, 18, 17? Everybody writing? Whole thing. Everything we doing, everything in this one. Right, except the remainder. We had to prove a PMI here too. Last one we do it, and then we do it logs in the season serves. What time I want to break? No. Or now start. How long the exam is? Right, so yeah, 2.5 at least sit down there for. Huh? For what? 2.5? Or we start 10:30. And we start late too. Yeah. Oh yeah. Do this in words fast. It is raining. P, it is raining. Q, it is John is sick. Oh, you're right, enough. It is not raining, or John is sick. Or is what? What symbol is or?
The down arrow.
Nice. So not raining is what? Not
P.
P, nice. And John is sick.
Q.
Next one. If it is. What's that? If then. What symbol is that? The arrow, right? Conditional. If it is raining is what? P in front. And John is not sick. Are you okay with that? That is your negation, right? Go and smell up in here, right? All right. Everybody okay with that? Go ahead. You have to prove it commutative. How are you doing that again? Using the matrix. So if they give you this matrix here, how you show it commutative? Aligned. You have to make sure that I do want in triangles. You have to make sure it's symmetric. Yes. So you have to show the matrix symmetric. I'll show you that now. Try it, look at try it. Go ahead. Symmetric means ignore the diagonal. Ignore that, right? But blank that off. The triangle on top and triangle underneath identical. Watch. So ignore this. Right? Ignore that. You have to show that this and this is the same. Are they the same? Yeah, but you have to give them an example. Yeah? You have to show them that 1 star 2 is the same as 2 star 1. And then you say, since it's symmetric. Here, exhaustion possible, right? William. Since like exhaustion, here possible, right? 1 star 2 is what? 1 star 2 is what? 4, right? Teresa? Sure. 1 star 2 is 4. So what is 2 star 1? 2 star 1 is 4. That's okay? But it's not enough to say commutative. So you have to also say now, since table or matrix is really a matrix, right? Since the matrix is symmetric, then commutative. It is Friday. What about identity? You see, one, two of these things missing in the summary I sent out. Send you our next one, right? A little bit longer. I don't want fluffy with that one of them. But that one's a little bit longer with a lot more things in it. But you show the identity. It means that when you multiply all the values by 3, you get back the value. So A by the identity will give you back A. B by the identity will give you back B. So check and see. 1 star 3 is what? 1 star 3 is, right? Going good so far. 2 star 3 is what? 3 star 3 is, right? So therefore, and then do the last one time. 4 star 3. How you look at it and figure it out? By just looking for the column that's the same as the first one. That's okay? This question tells to prove, but if they ask you to find it, they're looking for the 2 columns that are identical to the first one. Well, okay, online there, Harris, all good there?
So how you gonna write that as an answer, like in words?
Was that? And I wouldn't hear you. You might have a message, right? I don't know why this thing not working good. Talk again, let me hear.
Say yeah, no.
Nah, not hearing the message yet.
Huh.
You get that message man soon, right? Right? Let's prove the identity pass. So to prove the identity, how would you explain the answer in words? Which one? 1 or 2? 2, yeah. I can't do it now for you. So to explain the answer, you're gonna show them that 1 star 3 is 3, right? 2 star 3 is 2. Sorry, I meant 1. 3 star 3 is 3. 4 star 3 is 4. Therefore, right? Therefore, 3 is the identity element. Right? So you get to use extortion here. Happy now?
Okay. Just like that's
Yeah, but then when it's too big, we have. Huh? Try this one here. PMI. Right? Whenever you're doing a summation PMI, what you try to do? But if it looks like that. Right, try to bring in the symbol, right? Try to bring in the summation symbol. Okay? And then follow the steps. N equal to 1, prove it. N equal to k, N equal to k plus 1, prove that. Right? How are you doing that? Shivani, what to do there? Why there? It is here, no? Summation of something given here, 4n by n plus 1. R going from 1 to n. What do I put here? 8R. Say that? 8R. Yeah? R is 1 will give it this. R is 2 will give it this. R is 3. And then you follow the steps. N equal to 1, left hand equal to right hand. N equal to 2. Sorry, N equal to follow the steps I gave you, right? Right, so follow the steps. Anybody got it? If they got it, message QED, right? You guys are ready? Nice. Anybody online got it? Huh? Right, no online. Right, Adam got it too. Nice, Karina. Nice, all the QED is coming in. I'm gonna do this now. Last minute again. Right, let's run through all these steps here. Right, so it's the same steps for PMI, even if it's summation or divisibility, right? So first thing first, n is equal to 1, left hand side will be 8 by 1, which is 8. Right hand side, the right hand side, all you have to do is just plug it in the formula, right? So you'll get 4 by 1 plus 1, which is 8 as well. So therefore it holds. Okay, it holds for the first one. Now we want to assume true for n is equal to k. So the summation of r going from 1 to k of 8r is equal to 4k by k plus 1. Right, we're going to use this in the proof, right? Then we have to show it holds for. Show it holds for n is equal to k plus 1. So you will have the summation of r going from 1 to k plus 1 of 8r is equal to 4 by k plus 1 by k plus 2. That's okay? Now we're taking the left hand side. The left hand side is the summation of r going from 1 to k plus 1 of 8r. Watch here, right? For those who are lost still. Once you reach here, it's always this. The summation of r going from 1 to k of 8r plus the k plus 1 term. That's okay? This here is always this part here. Okay? So that'll be 4k by k plus 1. How do we get the k plus 1 term? Take k plus 1 and put it in here. All right? And you'll be left with 8 by k plus 1. Now we have to take that and try to prove this. Are you okay with that? What they both have in common? 4 and k plus 1, right? So they both have 4 and k plus 1 in common. And you'll be left with k by 2k here. Sorry, by 2. That's okay? And you're good to go? Right? That's it, QED. And you have to state here, since it holds for n equal to 1, n equal to k, n equal to k plus 1, then by proof by mathematical induction, it holds for all natural numbers, right? Right? Let's do some logs in the C's and C's and I'll give you a break. Bye-bye. Follow right now. Oh, yeah. I would normally give 8 now, but I'll start a little late. Right? A little behind. How is it 4 by k plus 1 by k plus 2? I mean here. Down there. In the last line here. Oh, because I factor out 4 and I factor out k plus 1. Well, remember 8 is what? 8 is 2 by 4, right? So I factor out that. Oh, right. When you factor out 4, you'll be left with k and you'll be left with 2. Because you'll factor out this and you'll factor out this. So you're left with k and 2. That's okay? All right, let's go again. Everybody write in. Finish right?
Yeah.
logs, indices, and surds, right? That's not right then. Right then. Right, so you're gonna take a look at logs, indices, and surds. Well, logs and really logs are gonna focus on, right? Already remember your log rules? Explain it again. So watch this here, right? So your plugin n is 1, left hand side equal to right hand side. Plugin n is k, and you get the statement you're going to use to prove, right? Then plugin n is k plus 1. You'll get k plus 1, k plus 2. And then when you reach here and you have to work with the left hand side, it's always going to be the summation of r going from 1 to k plus the k plus 1 term, right? How do we get the summation of 1 to k? Is always right here. That'll be 4k by k plus 1. How do we get the k plus 1 term? The k plus 1 term, put it in here. Put k plus 1 wherever you have r. So you'll get 8 by k plus 1. Instead of writing 8, write 2 by 4. Okay? Now you would recognize that they both have 4 in common and k plus 1 in common. So if you factor out 4 and k plus 1, you'll cancel up here. You'll get k, cancel up here, and you'll get plus 2. That's it. They're the same. Yeah? Yeah? Daniel, you okay with that? Eh? All right, let's go again. Right, so I want to focus, I want to run through the log rules. There's a new log rule, well, new for unit 1, right? There's a new log rule that we had to focus on, right? And the rule is, well, we should, let's run through the whole one, right? If you had to convert from indices to logs, if you have A, C is equal to B, it becomes log to the base A, carry across the B, and that's equal to C. That's okay? Once you have it in logs now, we have to remember log. You have to remember that log of 1 is always 0. Same base, addition sign, you multiply. Same base, subtract sign, you divide. Right? Power rule, take the n, you could bring the n in front. Are you okay with that? Trying to figure out where this epsilon x thing come on from. Anyway, suppose you have log log to the base e, right? Log to the base e of, let's say, 5. Log to the base e is the same as ln. So every time you see log to the base e, that's 5. Or every time you see ln, that's log to the base e. So if I ask you what is ln 5 plus ln 4, right? Because ln follows the same rules as log, all you have to do is say ln 5 multiplied by 4. That's okay? Are you okay with that? So every time you see log and ln, they follow the same rules. Okay? Ln is simply log to the base e. So, question. What is log to the base e of e? That's 1, right? So since log to the base e is ln, what is ln e? Ln e is 1, right? What is ln e to the 5x? You could take the 5x and bring it in front here, right? So that'll be 5x ln e. And we know that ln e is 1. So the answer is 5x. So ln of e to the 5x is simply 5x. All okay with that? Yeah. How do we go from base A to base C? We can do the change of base formula, right? So if questions are not in the same base, we could use this formula here to change the base. Okay, so that'll be log to the base A, log to the base A. Sorry, new base, right? C, right? C, new base here. So it will be log to the base C of B, log to the base C of E. Yeah? Right? So those are the rules. Now we have to be able to apply the rules. Right? Those are your log rules. Before I move on, how does the graph with E of X look? Or 8 to the X? Right? So the graph of Y is equal to 8 to the power of X looks like that. And this here is the inverse, which is log to the base A of X. Okay? So it's important that you know what the graphs look like. What you will recognize is that this Y value is never negative. See that there? That Y value is never negative. Okay, and what about log? What about log? Can you find log of a negative value? No. So you would recognize the log graph doesn't exist here. All right. Just some quick properties. So like when you're solving logs, if you have to find log of a negative number, you know that right here, you know that that value doesn't exist. All right. So let's try a few and I'll give you a break. Right, so those are your rules for log and those are your rules for log, right? Solve that fast. 22. This one like at mass level, right? Because it's same base, right? So we see how if you have to write at mass this year, what would happen? Take your time. Finish already. Right? I'm going to next song, right? Right, today is Friday. I'm in the CP as well. Huh? Right? How are you doing that? Right? So same base, addition sign means you go and multiply, right? So that's log to the base 5 of x plus 2 by x plus 6. Right? When you reach here, you could write 1 or you could write log 5. Anyone you want. Right? Since you have log on both sides, what you can do? You could drop the logs, right? If you do like that, you could have convert to exponential form, right? So you'll get x plus 2 by x plus 6 is equal to 5 and expand out. X squared plus 8x plus 12 is 5. X squared plus 8x plus 7 is 0. Do a little factorization here. You'll get what? 7 and 1. X is minus 1 minus 7. Both of them valid? Now, right? X equal to minus 7 is not valid. Right, look at it there. Right, if you plug in minus 7, you'll get a negative value. Right, so log of minus 7 is not valid. The only answer is minus 1. What you do is not the same base again. You gotta change the base rule, right? So look out for that, right? Sometimes it's easy like this, sometimes it's change the base. Right, remember we have some time before this, right? If you want to come in between your exams and practice some topics, you can come, right? Don't wait until June the all-nighter for the first time to see pure maths again, right? Once a week, just practice on pure maths, right? Ah, kitchen since 8 o'clock, and I use it. Whenever I use in here and there, and I'm casting is die fast. All right, let's go again. Next one. I think you're offering me up really low charge your iPhone. Hurry up. Try that fast. Indices. We had to buy something come before they give the change. You want to buy something? All right. Let's see what we got here. One more and then I'll give you a break. Too hungry or? Too hungry? Oh. All right, yes, now we're almost done. I'll give you a break after this one here. Right, the problem here, we had to make a substitution, right? So let's see what we have here. We have 6 minus 7 over 2 to the 2x minus 3, 4 to the 2x, right? Equal to 0. Right, right, so we could also write it like this, right? 7 over 2 to the x minus 3, remember 4 2 to the x is the same as 2 squared, right? That's okay. 4 will be 2 squared 2 to the x, which is the same as 2 4 to the x. Yeah, so that will be 2 4 to the x is equal to 0. All okay with that? Can I make a substitution now? Can I let y equal to 2 to the 2x? What will y squared be? What would y squared be? 2 to the power 4x? Yeah. So how will this look? So if I make the substitution now, what will happen? I'll get 6 minus 7 over y minus 3 over y squared is 0. How do I remove the fraction? Multiply everything by y squared. So I'll get 6y squared minus 7y minus 3 is 0. What's the next step? Factorize. How much you'll get? Anybody factorize it? How much you got? Y is what? How much? 3 and 2 and? Negative a third. So y is what? Y is 2 to the 2x is equal to 3 and 2. By solving that, we can't come with the same base, right? This has no solution, right? Why does the right hand side have no solution? Sorry, the second value have no solution. Huh? Right, because you can indices can be negative, right? Yeah. How we solving the left hand side? Take logs on both sides, right? So you'll get log 2 to the 2x, log 3 on 2. What about if it take ln? If it take ln, what will happen? Anything will happen? Nope. Get the same answer, right? So you'll get 2x is equal to log 3 on 2 over log 2. And then divide everything by 2. How much is that? Take log on both sides, carry across the 2x, and then divide everything by that. Yeah, and then divide by 2, yeah. 0.29. Okay, nice. All right, what do I do now? Give you a break now. All right, take a break. How long you want? 5 or 10? How long you need to eat? 15 minutes? No, not half an hour. That's too long. 20 minutes. It's 1 o'clock. I'm starting back 1:20 with questions. But we still have functions to do and alphabet and grammar. Plenty to do still. All right, online. The factorization, 3 on 2 and minus a third. All right, so solve it, Josiah, solve it. All right, online you'll have 20 minutes. I'm starting back at 1:20.
It's flip over and follow the graph.
Noble, everything here. Right, 1:20 we starting back, right? Those who don't want a break, continue to do the questions that didn't correct it for you. Right, Sarissa? Sarissa don't want a break.
Right, and this was doing real hard.
All right, you ready? 5 minutes from now, is it? That'll be half an hour. All right, online. Let's start back, right? All right, so let's start back. Let's just do like one or two more logs on indices, and then let's start the next part, right? Some functions. What's the one now we just did? 22. Right, next one, 21. Logs, try this here. How we doing this one? Online? You'll come back there? Eden, put it there. Rahul will come back already, right? All right, nice. Try this here. Man, if I give all 15, we that start after all. How we doing this here? Any ideas here, Israel? How we doing this? Right, change all to the same base, right? You can change it to which one? All to the base 2, yeah. It's always nice to go with the lower base. It don't matter. You can choose the next one. This is number 1D. Wait, no, yeah. Yeah, number 1D. Right, change the base. Change base 4 to 6, to 2, and base 16 to 2. All right, so if we convert all to the base, if we convert all to the base 2, you'll get log to the base 2 of x plus log to the base 2 log to the base 2 of x over log to the base 2 of 4 plus log to the base 2 of x all over log to the base 2 of 16. All right, then we have to work on the denominator. What is log to the base 2 of 4? Right, remember 4 is value 2 squared, right? And you can bring it 2 in front. So you'll get 2 log 2, 2. Casio people, you can just put it in the calculator and you'll see that, right? What is log to the base 2 of 16? You'll get 4. What do we do now? What are you going to do now? Multiply everything by 4. That could work. So you'll get you'll get 4 log 2 to the x plus log to the base 2 of x plus log to the base 2 of x is 7. What's the next step? What's the next step there? Yeah, sorry, thank you. 28. What's the next step? What's the next step? Can I factor out log 2 to the x? And I will get 4 plus 2 plus 1. Right? And then I could carry it on the next side. So I'll get log to the base 2 of x is equal to 28 over 7. So I'll get log to the base 2 of x is 4. And then solve x. That'll be x is equal to 2 to the power of 4, which is 16. Anybody got that? You didn't get to reach her? So you convert it all to the same base and work it out, right? Right, let's go again. That was 21. Let's check out 19. Try that fast. We kind of did one already. Try that fast.
What are you- see,
19. That's 19. Oh, yep. Are you done? Finish already? This one? Right, let's see how it worked out. So we could convert all toward base. So we could convert the denominators to the base 9, right? So that'll be 4 over 3 to the, sorry, 9 to the x minus 4 over 9 to the 2x. Okay, is equal to 0. We can let y equal to 9 to the x, and y squared will be 9 to the 2x. So that's 3 minus 4 over y minus 4 over y squared is 0. Multiply everything by y squared, and you'll get 3y squared minus 4y minus 4 is 0. And the what are the solutions? Y is what? 2, 1 minus 2/3. Right? So it means that 9 to the x is 2, 9 to the x is minus 2/3. No solution, right? And here you take logs, so you'll get log 2 over log 9. How much is that? 0.31. Yeah?
0.315.
Sorry? 0.32. Yeah, Andy, once it comes around, you know, what you will do is just tell me the exact value, right? Okay, let's move on. Let's move on, right? Let's take a look at functions. All right. Let's run through some of these rules here. I want to go on the board and draw some functions here, right? Some functions that we have to learn. And we take a look at some transformations as well. Right. So for functions could be what? Actually, I'm going to board for this, right? Right. So we need to remember a few things, right? We have different types of mappings. Right. What are the different types of mappings again? One-to-one, one-to-many, many-to-one, and many-to-many. But which of those mappings are actually functions? One-to-one and and many to one, right? These two mappings are actually the final functions. Okay. So we need to remember a few things about functions, right? We need to remember that functions. Hello, my marker, right? Right? So we need to remember that functions could be one to one, right? How do we show a function is one to one? What you do? Right? So the mathematical way is the calculated way, right? It's to say, well, check and see what is f of a, check and see what is f of b, and make them equal, right? And if a is equal to b, then the function is one to one, right? What's the next way? The vertical and horizontal line test, right? If I give you a function looking like this. You'll see now online there? I don't think so. If I give you a function looking like this, will that function be one to one? No, we can check the horizontal line test, right? And because the function cuts more than once, what happen? Not one to one, right? And you can see that here. You have one y value and you have 1, 2, 3 x values. Okay, so it's not a one-to-one function. That's okay. But if you do the vertical line test here, what will happen? It will pass the vertical line test, right? So you have to use both of them, horizontal and vertical. Okay, you have to use both horizontal and vertical line tests. Right. So a function could be one to one if it follows those rules. What about on two or surjective? What must happen? For a function to be on two or surjective, what must happen? It means that the range must be equal to its codomain. Okay with that? So if a function is on two, and what would happen if the function is both one to one and on two? It's said to be bijective, right? It's said to be bijective. And if a function is bijective, then what we can do? What we can do? Right. If a function is bijective, we can find the inverse. All okay with that? Right, and how? Well, I cannot give you the answer, but suppose I give you a function y is equal to a to the x. How do we get the inverse of y is equal to a to the x graphically? Right? You reflect in the line, y is equal to x. Right? So if I reflect this function, I'll get this function. And this function is the inverse of this. But okay with that? Yeah? So we have to be able to reflect, right? To reflect, what is do? To reflect in the line y equals to x. If this point here is 0, 1, to reflect it, what is do? In the line y equals to x. Switch the values around, right? Okay? If you reflect in the line y equals to x, what you do is you flip the values around. Okay, the x becomes the y and the y becomes the x. All right, so we need to be able to do this. You will see this in a few years, right? Where you have to be able to find the inverse graphically. Okay, so since it's graphically, there are a few functions that we have to learn. We have a few functions that we need to learn. Right, so there are a few standard functions that we have to learn. Catch them fast, as long as I'm mark. Catch them fast. Okay, we can. Right, so these are some functions that we need to learn. Right, so y equal to x looks like what? Nice straight line, right? Y equal to x squared looks like this. Y equal to x cubed looks like what? Something like that. Most important one. Y is equal to 1 on x. How does it look when a is more than 0? Well, x is more. How does it look when x is more than, well, I'm not sure that, right? When x is more than 0, it looks like this, right? And when x is less than 0. These two lines are called what? Right? The y-axis and the x-axis are called right? Those are the called your asymptotes. What it means that your function should never touch those lines, right? They are called asymptotes. Are you okay with that? So from this now, we need to learn all transformation. I think I have it in the summary there, right? If not, let me just forward this new summary. What is your name? Probably summary. Unit 1 summary. Alright, wrong one. Anyway. I'll look for that, right? Right. Let's start. Let's do a few. Let's do a few transformations first. If I gave you, right? If I gave you f of x, right? And I put a minus in front, what you do? Minus f of x. What does it do to the function? It'll make all the values what? So if I apply that here, what will happen? It'll look like this, right? And it should make sense, right? A minimum going to a maximum, right? What would happen if I add e on the outside? What you would do? Plus a means all the values will go up a. Minus a. All the values will go down a. What about if you had f of x plus a? Would it shift to the left or right? To the left, a. What would happen if you had x minus a here? It would shift to the right a. Okay. So if I give you something like this now, y is equal to minus 1 over x minus a. What are the shift this graph undergoing? Minus. So what? what will happen? Positive will become, negative will become, and then x minus a means what? To the right hand. So the whole graph coming to the right hand. That's okay? Yeah? So you have two shifts here. You're reflecting the line in the x-axis, then you're shifting it to the right hand. Right? We'll do an example that's now. And what about a f of x? Vertical stretch. This is a vertical stretch. What about f of ex? What would it be? It will be a horizontal stretch by a factor 1 on 8. It's kind of like a shrinking out. Right? So you're dividing by 8. And then an important function called the modulus. What's the modulus? Modulus means what? You only want the positive values, right? So if I give you something like this, what is the modulus of? What is the modulus of x cubed? Modulus means the part of the graph that's below the axis will come above. Not the best, but you see what I'm talking about, right? So you reflect this part above. Okay? While we are on modulus, we need to understand the definition of modulus. Right? And you see the definition right here. Here's what the definition says. When x is more than 0, right? We're okay with it. We leave it as it is. Right? But when x is less than 0, we don't want that. So we have to reflect it here. So we put minus x. That makes sense? That's the definition of modulus right here. Right? When x is more than 0, which is right here, we're leaving it as it is. So we're leaving it as x. Right? When it is less than 0, which is here, we don't want this part of the graph. We want to reflect it. So you put minus x. Everybody okay with that? So these are the rules that govern modulus. Yeah? Let's try one. Right? So we have two to do. We have to find a way to sketch this and then sketch that, right? So what's the transformation here? Transformation here is what? Just modulus, right? That's okay? Just modulus. So how will it look? Would it affect this side? No. What will happen here? Very flat. Yeah? That makes sense? Shoot? No, just number 1. Right? Number 2, the next one. Are you okay with that? Shoot, cover. You sure? You sure? You have with number 2. Ready? Try that one there, please. You gotta remember what composite function something, right? F into G. Any questions online? We're just trying this one here before I move into our past paper, right? Right, we have modulus to do. Oh, I cannot show you modulus. I'll show you how to solve it now, right? I'll show you how to solve a modulus examples, and then we take a look at alpha, beta, gamma. Actually, we could do this one time. We are real time. Real time. What's that? Oh, I don't know, you're not tomorrow break, but I get 33 minutes with 33 minutes all again. Me? I was here 20 minutes. I don't want to say so. I'm gonna go 5 minutes. So I give all the 5 minutes. So yes. Huh? I didn't get nothing to mind. All right, let's see how this one. Right. So I'm just going to go through all these stages. You don't have to do this, right? I am just going through all these stages. So first stage, we have to know where it came from. That's okay? Then we'll do the plus 3 first, it don't matter. Plus 3 means what? We're shipping it upwards. So if we ship it upwards, the asymptote is no longer y is 0. It will now become y is 3. Okay? The asymptote is now y is 3. So it will be here, it will be here. That's okay? That's incomplete. Huh? What does this here mean? It means to the right 2. So you're bringing it to the right 2. So this is x equal to 2. This is y is equal to 3. That's okay? So we shift the whole graph up to the right. So your asymptote look like that. That's okay? SL, you sure? Right? Right. I have a quick question here, right? Real quick. That's not. So what does it say over here? Oh, that's the modulus. Oh, it didn't show up. Sorry. This first part here, x is more than 0. This part here, x is less than 0. All right. What I was saying there? Oh, I had a quick question here, right? Go watch here. What 5? Is that 5? Half 3. I'll let them go today. Half 3. Huh? About half 4, 5. 4. We'll start with 4 and then I'll push it up. Right. Question. Anybody? How are we going to sketch this? We'll see who remember. How are you going to sketch this? This not looking like any, right? Huh? Right. Long divide. You have to long divide this. So you'll get x minus 2 into 3x minus 5. X into 3x's. 3 by x's. 3 by minus 2's. And then a subtract. You'll get 0 plus 1. So the answer is what? The answer is 3 plus this the remainder, right? Remainder over this. That looks easier now? Yeah. That's the same thing, right? That's okay? So to sketch this, that's the answer. So to go from here to here, you got a long divide. Yeah, look out for that, right? Okay. And I just want to show you how to handle a modular question. Well, the way I will do it. How you solve modulus question? How you solve a question with modulus? Square both sides. You can square both sides or you can use the rule, right? I don't really like to square both sides, so I would ask you to use the rule, right? Right, last thing. How do we solve something like this? We still have alpha and beta and gamma to do, right? I'll leave that for last. That's just a few rules and then we'll practice on the questions, right? This is somebody had a stuff. So watch this here. How do we solve a question with modulus? In order for us to remove the modulus, we have to consider both cases. Or you can square both sides. Right? I like to use the rule, right? So when x is more than 0, the modulus is just x. So you're solving 3x minus 4 is 2x plus 1. Carry it here, you'll get x is 5. That's okay, Keshav? Right? When x is less than 0 now, right? What to do? When x is less than 0, wherever you have the modulus sign, you put negative value. Well, negative x. So it will be 3 by negative x minus 4 is 2x plus 1. That's okay? So you're doing it twice. You're doing it with the more than sign and with the less than sign. When you work this out, carry this here, you'll get minus 5x is 5, x is minus 1. So these are your two solutions. That's okay as well? Fair? So these are your two values, and that's the way you solve modulus, right? Take off the modulus sign, use a plus sign. Take off the modulus sign, use a negative. Right? Let's try some function questions. So what answer did you get for long division? When I long divide, I got 3 and the remainder is 1. So I wrote 3 plus 1 over x minus 3. Any questions? Let's start here. Let's start here with the modulus. How are we doing now again? It will become 20 plus 9 and it will become 20. Try this first. So you do it with the plus, you do it with the minus, right? Is that inequality here? Remember, it's an inequality, right, Olia?
This is my thing. Basically.
Right, so it should be done. So you will get 3x plus 2 is more than 4. 3x is more than 2. X is more than or equal to 2/3. That's okay? Then if you have a minus here, carry across the minus, you'll get 3x plus 2 is less than or equal to minus 4. So you'll get 3x is less than or equal to minus 6. Yeah. So you just combine both of them. Are you okay with that? Remember, when you carry across the negative to change the sign, right? Any questions there? That was easy, right? Right, there's a little what, 2 marks there. 5 marks of that. Yeah. To prove this? No, otherwise it's solution now. Now, once you write the final answer union here, you can do that. Some people will just draw it to show you what it is and check for overlap. Any overlap in this one? No. Right, so sometimes when you do this method, what you do is just check for overlap. Right, so you can tell them where the solution is here or here. But no, you don't have to do a number line. If you want, you can do it just to make it look like you have some more working. But as its solution will be that. Right? So you have your logs, you have your inequalities. Oh yeah, we have function here. Find the inverse. I know I didn't tell you how to do it, but you remember how to find the inverse. Let y equal to interchange x and y. Remember that? Find the inverse and then you have a composite function part here.
So it's the same time.
Yeah, same 2022. Find the inverse faster. Right, where did I put this next summary, boy? All right, so you should be done with that. So y is equal to 3x plus 1 over x. Then you interchange x and y. Then you solve for y, right? So cross multiply. Xy is equal to 3y plus 1. Bring all the y's together. And then what? Factor out the y. And you'll get y is equal to 1 over x minus 3. That is your inverse, right? You got 2. Easy marks, right? Next. Write down g of x because you need it. Because you have to find f inverse g. You have to find f inverse g. F inverse g, not O. That's not O. I don't know why they put up. Yeah. So they want you to find f inverse g of x. F inverse g. I said the next summary, right? Anybody else need it yet? Turn on the airdrop now. Ignore it. If you don't need it, you can ignore it, right? Sorry, you can take it. You can start learning that now. Right. How do we find an f inverse g of x? Right? All it simply means is that g of x has to go into f inverse. So g of x is e to the minus 2x plus 1. So f inverse e of minus 2x, coming back here for g inverse, for f inverse, that will be 1 over e to the minus 2x plus 1. So you'll get 1 over e to the minus 2x minus 2. Anybody got that? Easy marks again, right? Sometimes the functions come easy like that, right? Right, so I sent you a little more detailed summary, right? If you don't have it, just send my WhatsApp, I'll send it back. 21. What they ask us here? Nothing here, nothing here. So you have to do that already. Do that, do that. Aha, nice one here. I might have to help you here because it's kind of hard to draw it, right? All right, but anyway, that's what they give you. Do a quick little sketch now. I understand yet. Right, just send back a WhatsApp now.
Yeah.
Send it back a WhatsApp and I'll send it, right? Anybody online who need it, just send my WhatsApp. Right, so I need some help. They want to sketch the inverse of x. What's the line that we have? What's the line that we have to draw? What's the line that we have to draw? In order to sketch it, we have to draw the line. Nice, Chelsea. Chelsea said to draw the line y is equal to x. Where is that? Somewhere here. Let's start over. What's going on with this thing? All right, I must try one more time. Catch it there, see? Right. That's the line y equal to x, right? Are you okay with that? How do I get a reflection? Let me pick on somebody. Yeah, pick on you. Is here? I see a pop behind it. Rajiv, how is it reflect again? In the line y equal to x, how is it reflect? Just switch the x and y values, right? So you just read off a few and switch it. Right? So, well, you'll need more than 2 points here, Chelsea. So let's start here. That value looking like what? 1, 2. Yeah, you can fold the page and write it. Right? Right, but no, I'll just do it. Can't really fold the page under it. Right, so 2, let's flip that and I'll give you what? When you flip 0, this value here, that value there is 0, 0, 2. That'll become what now? 2, 0. Where is 2? 2 is here. Right? See the difference? It's not here. Let's pick the next one. Which one I can use to read off there? Let's read off this one here. That looked like 0.6. That value there looks like 0.6. That's the x value. And the y value looks like halfway, 2.5. So we're switching it around, 2.5, 0.6. 0, 1, 2, 2.5, where is 0.6 now? Where's 0.6? 2.5 is here. Every small block is how much? 0.5. So I'll have to average, right? Somewhere there? Are you confused? Are you confused? I'm going to show you, right? All I'm doing is this. Right? Anyway, I shouldn't rub it off, right? All I am doing is this. To reflect this line, all I have to do is read off some points and just flip the points around. So the first point I chose was 0, 2. I choose our next point here. I'll choose our next point here, a next point here, a next point here, a next point here. And then I'll get a reflection. All okay with that? That's all they're doing. All right. So just do a little sketching. I know you don't have graph paper. Right? Just do a little sketch. Make sure you have the line. Make sure you have the line y is equal to x. Right, so it might look something like that, right? All okay with that? We're not looking too good there, but we gotta actually plot it, right? All you're doing is taking the x bar, x and y, and flip it around. Are you okay there? Saskia, you okay with that? How are we going to show the function? What we have to do, right? Do the horizontal line test and the vertical line test and show it cuts only. Show it only cuts once. Okay? Show it only cuts once, right? All right, but you could do it in a sketch, please. Just do a quick little sketch and show it, right? Use a different color line or a broken line or something. Right, so you have your vertical line and your horizontal line. Test and show it in cuts once. So the function 1 to 1. Right, my graph not coming out good because I keep having to shift it, right? My line keeps shifting, so. Online, you all okay with what to do? Adam, Hello, kid, what to do? Shania, are you okay? Anybody have graph paper and actually did it on a graph book? You see it? Just plot it and do it. All right. Anyway, I move on. Let's move on, right? Brothers, can I explain to you what to do? Prove f is 1-to-1. How are we doing that? We'll have to do it. If they say prove it and they already kind of show it's a function here, we'll have to do it mathematically. Okay, so let's see if we could prove this here. F of x is x squared plus 1. Right? Check it out fast. F of A, F of B. Check and see if A is equal to B. Quickly. Are you ready? Right, what you'll get here. So you'll get x squared plus 2. Sorry. You'll get a squared plus 2 is equal to b squared plus 2. Right? And well, the 2 will cancel, and you'll get a squared is equal to b squared. And a squared, sorry, when you square root both sides, you'll get a is the square root of b squared. So a is what? Plus and minus b. But what? since x is more than or equal to 0, it means that a could only be equal to positive b. Therefore, that's okay? Therefore, function is 1-to-1. Right, so because the function is more than 0, more than or equal to 0, right, we'll recognize that f of x is 1-to-1. Next one. All okay online there? Any questions online with that? All right, last part. Take it off, right? Last part. You want to show that the function is on 2. How are we doing that? Right? Range equal to the codomain, yeah? Check and see what they gave you. Oh, I turn back here, right? Yeah, any ideas here? Real fast. Any ideas here? How are we showing this? What's the problem here? It didn't really stay the codomain. You realize that? So although we can figure out the range, what's the range? What's the range at y is more than 0? Codomain is, the domain is the horizontal values, right? And is x is more than or equal to 0. And range is what? Range is the vertical values. So here your range is what? All the values are more than or equal to, from the graph it looking like 1, 2. All the values appear to be more than 2. So the range appears to be y is more than or equal to 2. That's a range. But we don't have enough input from the graph to do the codomain. Okay? Normally, if you have the codomain, you can just compare them right there. All right? So if you do have that, what we can do? If you do have that, what we can do? Right? Just 1 second. Yeah.
But it's fine.
Yeah. So.
All right, sorry there. Right, yeah. So, what are we doing again? We're trying to show onto, right? So basically for onto, we want to check codomain and range and see if they equal, right? Right? So if that doesn't work out, right? What Adam said here, you can check and see if it have value. So y, right? Yeah, find a value for y which x doesn't exist. Right? So you're checking to see if there's a mapping. So what we're gonna do, we're gonna try to get a value from the codomain and a value from the domain and see if we could map it back. Right? So one of the things that we could do is this. The question gave us f of x as what again? X squared plus 2. So what we could do is we could solve for x. Solve for x, right? And what we'll get? We'll get x squared plus 2 is equal to y. X squared is equal to y minus 2. X is the square root of y minus 2. Okay. Then we're going to take that x value and put it back into y is equal to x squared plus 2. Right? And what should happen? Well, you're actually finding this, right? You're actually finding f of x is equal to. So let's put that x value. That will be the square root of y minus 2 which will be the square root of y minus 2 squared plus 2. This will be y minus 2 plus 2, and what we getting back here? We're getting back y, right? So we took this value for x and we're getting back a value in y. So what does that mean? It appears to be onto. Okay, it appears to be onto. All okay with that? Right, let's go again. What year was that? 21. Try this fast. 19. 19, try this fast. Show it 1 to 1. Show it 1 to 1. You can do this catch if you want and then do the test. Right? But here you can do the f of a equal to f of b and see what you get. I like this sketch because catch it for all the values more than 1. Right? If you use the f of a, f of b method, you want to complete this square and thing, huh? You want to complete this square. If you don't want to complete the square, catch it. If you complete the square of x squared minus x, what you'll get? What is h and what is k? Complete the square means this, right? What you'll get? I'll show you both methods, right? Complete the square. How you find h again? H is b over 2a, right? So that's minus 1 and 2. So that's minus a half. That's okay? So that will give you minus a half then. And then you get k. K is what again? K is equal to c minus a squared. C is 0 and a is 1 and h is negative a half squared. So you'll get negative 1/4. So when you complete this square, you will get something like this. Right? Hopefully that's helpful. If not helpful, just sketch it. If not helpful, Grant. And at least you're honest. Take a 2 minutes. Or you can sketch it. It's a quadratic, right? So you need like a little turning point. You don't need a turning point, really. Where it cuts the x, where it cuts the y, and it should be all right. Right, grand. Sister to say it's not helpful. What's f of e? What's f of e? Right, and what's f of b? But you see the problem, you can't really cancel anything off. See that? So you had to find a way to do it, right? And the way to do it is to complete the square. So if you complete the square of a squared minus a, what you'll get? A minus a half squared minus 1/4. Correct? And if you take b squared, what you'll get? B minus a half squared minus a quarter. For 6m, we have three. Right done. B,
Drastic would be like this.
No.
Somewhat from
A plus B, right? So the only way to simplify that, I will not run around so much tomorrow, yes, sir. Right, this will cancel. You can square root both sides, you'll get A half is equal to B. This will cancel. And you'll get A is equal to B. Are you okay with that? Right, and graphical, oh, sorry, you're right, so graphically, you have to sketch it. Well, you're alive or tired? Tired? Right, so sleep good today, so we'll come back tomorrow. Tomorrow will be even harder because I won't be up and down tomorrow. I'll be right here. Right here. And no break because I'll get all the extra time today. Right? Right. One thing that we had to point out here, right, is that when we find the square root, right? Remember, when we square root b minus a half, you're going to get plus and minus. But what do we know? Right, we know x is more than 0, x is more than 1. That's okay? So therefore, we do have the negative side. So we will end up with a is equal to b. If you all do like this method, there is the next method. We can catch this real fast. It cuts the roots, it cuts at 0 and 1. That's okay? But do I want all these values here? No, because the function is defined when it's more than or equal to 1. But okay with that? Then you do your horizontal line tests and vertical line tests if needed. But okay with that? I like this sketching it easier if you could sketch. If you can't sketch, well, stay away from now, right? That's okay? Let's go again. Find that fast. And then let's do some alpha beta gamma now. Right, I feel I had to do some more of that tomorrow. Sorry? Everything. I didn't get a touch 18 out yet. I'll give you a homework, but you wouldn't do it. Well, all nighter. All nighter is questions you never see before. For the all nighter, you have to know some work, right? I expect you to know some work because the exam is 2 days away, right? Why are you doing it so? So hopefully you remember it. Now I might do 2, you know. I might do an all-nighter and like a crash course like this. So if you need it, those who real bad will come to crash course. Those who just need the extra work, right? But I'll message on the group around the enemy and I'll say if you remember anything in pure maths, I'll give you a question to do, some multiple choice. Right? If you score more than 70%, come to the all-nighter. Alone. No, I don't know. I didn't figure it out yet. But I might do 2 things. I might do 2 things, right? I might do a 1 day or 2 days like this, and then I'll definitely do the all-nighter. But the all-nighter, assuming you know some work.
Yeah.
The crash course will be assuming you don't know anything, which is where it might be in a one time. Oh gosh, I'm sorry. Hurry up, do that fast and then let's do some alpha beta. Same here. 19. All right, we're taking too long. What's the inverse here? You can do that mentally. People are not working good. Yeah. It'll be x minus 1 over 3. Nice. And what is f inverse, g inverse? Sorry, f inverse g of x. Just put that there, right? All okay with that? All right. Let's do some alpha beta. Will you find that hard? Because they give you the rules now, right? So it shouldn't be so hard. I don't do anything hard now and frustrate people. Right, let's take a look at alpha, beta, gamma. Bell gone ring now, right? So hurry up. Right, this here the new summary. Spend some time and go through it, right? Right? If you didn't get it, send my WhatsApp, right? So let's take a look at alpha, beta, gamma. Right, these are all the transformations. I'm making right down this now, right? Right. So if I give you a cubic, cubics are, sorry, that's quadratic. If I give you a cubic, they are generally of the form ax cubed plus bx squared plus cx plus d. Sum of the roots is what? Minus b on a pairwise sum. Pairwise sum means you're pairing it up and then summing it, right? Pairwise sum is C on A and product is minus D on A, right? That should be alpha, all right? And these are some rules that you have to learn: alpha squared plus beta squared plus gamma squared. But the good thing is, in most of the years, they give you that. They're giving you it. All right, Ver? In most of the years, they're giving it to you, so you don't really have to learn it. Right? But you should still have an idea, right? General form, x cubed minus the sum of the roots by x squared plus the sum of the product of pairwise sum minus the products. So every cubic can be written like this. All right? That's kind of what you have to learn, and then we could try a few years, right? All right, let's try we didn't touch 18 for a little while, so let's do 18. Right, as an example, I will do 18 together with you, right? You all seen it there?
Yeah.
Write it down now, please. Fair excuse. Almost done. You can write it down.
Thank you.
2018. Write it down. So do we need to know how to solve modulus functions graphically? If they are only if they ask you. Right? But generally, modulus questions, you solve modulus questions using the algebraic method alone. All right? Not much help there, Binish, but basically, you solve it algebraically, right? Never ask you it with graphically, like graphically, solve it graphically. No, not like that. All right, good. So let's see if we can find the equation whose roots are that. So how do we get the equation again? X cubed minus the sum of the roots. So write it first. Alpha squared plus 1 on beta squared plus 1 on gamma squared by x squared plus the what? Pairwise sum, right? How do you get pairwise sum? How do you get pairwise? You multiply this by this and this by this, right? So you will get 1 on alpha squared beta squared plus 1 on alpha squared gamma squared, and then one more. Multiply this by this. You will get 1 on beta squared gamma squared. That's okay? That's a pairwise sum. And lastly, your product. Your product is 1 on alpha squared beta squared gamma squared equal to 0. Right, so how do we get 1 on alpha squared plus 1 on beta squared plus 1 on gamma squared? Not yet. No, remember that is alpha. All right, yeah, actually, I'm gonna find that first, right? What is alpha plus beta plus gamma? That's minus B on A, right? In this question, we have A as 2, B as -1, C is what? C is 0 and D is 1. Right? So minus B on A will be a half. Yeah? What is the product? Alpha beta plus alpha gamma plus beta gamma. That's C on A, right? C on A is 0. And then the product, alpha beta gamma, is minus D on A, which is 1 on 2. Minus 1 on 2, sorry. What's the next step? How do we get this here? Yeah. How do we get that there? William, how are we doing now? This part here. Right, find the LCM and work it out, right? So what will the LCM be? The LCM should be 1 on alpha squared, 1 on beta squared, 1 on gamma squared. The LCM is alpha, beta, gamma, all squared. Correct? And the numerator is what? Alpha squared, beta squared, plus alpha squared, gamma squared, plus beta squared, gamma squared. Right? And as I said, there's normally give it to you. Look in numerator right here. You'll see that? And the denominator, well, we could figure that out. So the numerator is what? So the numerator will be alpha, gamma, beta, so on. That's 0 squared minus 2 by negative a half by the sum. The sum is a half. All over alpha, beta, or beta, gamma, all squared. That'll be minus a half all squared. How much is that? That's a minus and a minus, a plus. I have minus a half, sorry, plus a half over quarter 2. Yeah. Anybody else got 2 there? Nice. Will it always be 0? No. It's based on the cubic they give you. Right? So it's based on the cubic that you have. How are we getting this now? How are we getting this? LCM again. So when you find the LCM, you'll get alpha squared. Same thing underneath. And numerator will now be alpha squared, beta squared, gamma squared. So we know here what alpha squared, beta squared, gamma squared. That will be a half squared minus 2 by 0. How we getting the last one? How we getting 1 on alpha squared, beta squared, gamma squared? That'll be 1 over alpha, beta, gamma, right? Oh, wait. I left out part here. I left out a piece here. That'll be minus a half squared. So I got 1. You got one? Anybody else got one online? Yeah. Nice. And last part. 1 over alpha squared beta squared gamma squared. That'll be 1 over minus a half squared, and you'll get 4. Right? It's a little bit long, but it should be easy. Because it's the same thing over and over. Next one I'm going to give you just like this. Sorry. Yes, one more after this and we're done. So we got a half, we got 1 and 2, and you're done. Go back to the original thing, and you'll get x cubed minus 2x squared plus 1x plus 4. One more we done. One more. It's just another shot now. So imagine 12 hours at this. Subtract 4, get minus 7. Minus 4 times. Right, so all we need to do, we need to find the sum of the roots, the product of the roots, and the pairwise sum. A little bit long. Right? One more and we're done. I tell you why. Look at a way to do it. Last one and we're done. That was 18 there, right? Right, Tinsel? All right, last question, and that's it for today. Last question. I don't know what year it is, so don't ask. Huh? Nah. I ain't doing that. Okay, that's fast, very easy. Not yet. What's that? You are by the take it up for there. Okay, so don't worry. 2x cubed minus x squared plus 3x minus 1. All seen that? That's the equation there. And then they want you to, they give you all of that.
Wow.
Oh yeah. Find an equation whose root is that. I'll check it individually and then you can go.
Wow.
Faster you do it. Right, they want to find the roots, one on alpha, one on beta, one on gamma. And they help you out. They tell you what the pairwise term. Don't know why, and they give you one on that, and it gets to your term. You really need that, take to this one. There's a next way to do it, but remember it? That y equals to this, no? Come on, next, right? Find that one short. Last one does it. So the new roots are one on alpha, one on beta, one on gamma. Right, find the sum, the product. Pairwise sum. Finish already? Go. Just so fast. All right, good. You can go. Grant this door. I like to go again. Yeah. All right, try one. First one,
I get to the front.
Right, last thing, let me just do it fast here and all you go. Last thing here. What you all got for alpha, beta, alpha plus beta plus gamma? A half. What you got for alpha, beta, alpha, gamma, beta, gamma? 3/2. And what you got for alpha, beta, gamma? A half. Okay, nice. So 1 on alpha, 1 on beta, 1 on gamma. The LCM is this. And you'll get alpha beta, alpha gamma, beta gamma. So you'll get 3 on 2 over half, which is 3. Positive 3, right?
Yes, yes.
So what's your signs, right? 1 on alpha beta, 1 on alpha gamma, 1 on beta gamma. Same LCM, you'll get alpha plus beta plus gamma on top. So that is a half divided by a half, which is 1. Alpha, beta, gamma, that will give you 1 over half, which is 2. So the answer is x cubed minus 3x squared plus x minus 2.
Yeah.
Okay,
So where was the?
2022. That was 2022. All right, that's it.